Typo tolerance is easy until filters enter the query. Typesense gives you fast facets and typo-tolerant search in one Python workflow. You'll walk away with a setup that handles misspelled searches and surfaces filtered results aligned with a chosen facet. I'm Professor Pi, teaching search and IR with simple Python. Search systems run into the same snag. Users mistype queries but still expect the right results. At the same time, product teams want quick faceted filters for things like category, stock, and price. If you handle typos naively, you either ignore the filters and return fuzzy junk, or you enforce filters and lose fuzzy hits. Typesense solves both by letting you keep typo tolerance and fast faceting in the same index. Put simply, the engine should forgive small typos and still obey the user's constraints. If someone types sneak instead of sneak, city sneak should appear when the user filters for shoes in stock below a price cap. The goal is a ranked list that tolerates the typo while facet counts and filters remain accurate. We'll build a tiny catalog, index it in Typesense, and then run searches that mix typo-tolerant queries with filters and facet refinement. Keeping the dataset small makes it obvious how each step changes results. Quick note, this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. To start, we confirm the Typesense node is reachable before we touch data. This snippet configures a Typesense client and checks the node health. Connection failures are the first reason typo tolerance collapses under load, so we confirm the service before tuning relevance. The client dictionary mirrors a local node setup, keeping latency controllable for debugging hybrid retrieval flows. Calling client.health.retrieve gives immediate feedback if the host is offline or misconfigured, saving wasted indexing work. The printed status shows the server responding, which means we can trust subsequent search benchmarks. With the node healthy, we need a predictable schema that supports faceting. So we reset the collection and define the fields we will filter and facet on. This example resets a faceable Typesense collection ready for filtered catalog search. Schema drift causes filters to fail silently, so we clear the stale collection before defining fresh fields. The fields list flags category and stock for faceting, while keeping price numeric for later range checks. Calling client.collections.create ensures the server stores the exact schema we expect to query. The printed facets confirm Typesense registered the fields we need for future typo-aware filters. Next, we push some messy data that includes likely typos and variant names to see how fuzzy matching behaves. This code loads typo-prone catalog records into Typesense and verifies fuzzy matching accuracy. Misspelled product names derail classic filters, so we bulk import a JSON-L payload to mimic messy inventory data. Client.collections, catalog, documents import, streams the 3 rows in one shot without recreating the collection. The search dictionary uses Q equals sneak and query by equals name to invoke built-in typo tolerance against our noisy names. The printed hit shows city sneak surviving the typo, meaning the index is ready for faceted filtering. Now we combine typo-tolerant search with a concrete filter and ask for facet counts that reflect that filter. This snippet applies a filtered Typesense search with simultaneous facet aggregation. Leaving typo search unchecked would hide out-of-stock items, so we constrain hits by stock true and a price ceiling. Facet by requests category and stock, letting Typesense compute counts that already respect the filter by clause. The facets comprehension normalizes the API response, making it easy to compare buckets downstream. Lowering the price cutoff tightens available inventory, while raising it would bring the boot facet back into play. The printed category facets show that only the shoe bucket survives the filter, proving the aggregation stayed aligned. Finally, we test what happens when users also misspell the facet value itself, and we want the facet refinement to be forgiving. This example keeps typo-tolerant facet refinement active in Typesense when filters are stacked. Users often misspell facet values like shoe, so we add facet query with the typo shio to simulate that UI mistake. Facet query num typos equals 2. Let's Typesense fuzz the facet match while the existing stock and price filters stay in force. Increasing facet query num typos further widens the bucket and risks cross-category matches, so keep it tight. Setting per page ensures the hits array stays populated for inspection. The printed names confirm the facet typo still surfaces City Sneak, proving faceted filtering stays usable under errors. In a real project, you would map this toy flow to your product catalog. Use the same fields and filters inside your live schema, and run timing checks on search latency as you add more documents. Recap: Typesense gives you typo-tolerant queries plus correct faceting on the same index. Use this when your users spell things unpredictably but still need accurate filters and counts. One caveat: fuzzing facet queries widens buckets and can introduce false positives, so tune the fuzz parameter cautiously. Next step: tune facet query num typos or your typo tolerance settings to balance recall and precision on your full catalog. Then measure latency and bucket purity. If short, practical IR helps, subscribe and watch the IR videos.